everyone, I'm Professor Huntington, and today we're going to talk about estimation techniques. I also want you to know that I've created some guided notes that you can use while watching the video to help you with your note taking. So look for those in the course. While we're going through the video, I'd also like you to think about why would somebody want to estimate an answer instead of arriving at an exact answer in real life? How does this help us? And so that leads into what estimation actually is. It's arriving at an approximate answer, and so we're going to round the numbers to estimate this answer. And when we have an approximate answer, we denote that in mathematics with these squiggly equal signs, which means approximately equal to. Estimates are not meant to give exact values for answers, but they are means of determining whether your answer is reasonable. And in the next section, we're going to talk about problem-solving techniques and the 4 phases of that. In the last phase, I'm going to ask you to look back, and while doing that, you're going to ask yourself if your answer seems reasonable. And our estimation skills from this section will help us with that. So I'd like you to pause the video in a second and ask yourself, what is the difference between rounding and estimating? Okay, and so what I came up with is that with rounding, what you're doing is you're calculating the exact answer first, and then you're rounding at the end, because maybe you have too many digits. For example, with money, let's say you have an answer that comes up to the thousandth spot. And in money, we really only want to the penny, which is the 100th spot. So then you would round to the nearest 100th, things like that. With estimating, you are rounding the numbers first so that they're a little easier to work with. And I want you to think of always doing mental math with estimating, because you're rounding these numbers to a number that you can easily do without a calculator. And that's how we're going to estimate. So the difference is with rounding, we find the exact answer first, and with estimating, we round the numbers first and then do our calculations. Let's look at an example here. So estimating the cost of chocolate chip cookies. Mally decides to purchase chocolate chip cookies for a party. Let's estimate her cost if she purchases 21 cookies at $1.95 each. So let's imagine being in the store, and yes, now we all have smartphones, we could pull out the calculator, but let's just come up with an approximate answer a little more quickly. So 21, what do we think? What could we round that to? Okay, probably 20, and $1.95. That's pretty close to $2, right? So when we do this, these numbers are now a lot easier for us to calculate without a calculator. And so 20 times $2 is going to be $40. So her approximate answer for all these cookies would be about $40. But the important thing here is to notice that we rounded the numbers first and then did the calculations. And the way we write it is with the little squiggly equal signs, and so it's approximately $40. Okay, let's look at another example. Using estimations in calculations. The Travis family traveled 1,276 miles from their home in Portland, Maine to the Gateway Arch in St. Louis, Missouri. Here's that arch. So if their trip took 19.9 hours of driving time, estimate the average speed in miles per hour that their car traveled. Let's look at another example of using estimations. So the Travis family traveled 1,276 miles from their home in Portland, Maine to the Gateway Arch in St. Louis, Missouri. Here's a little pic of that. So if their trip took 19.9 hours of driving time, estimate the average speed in miles per hour that their car traveled. Okay, so here we have 19.9. Doesn't tell us what to round it to, but that's pretty close to 20 hours. Now let's think about this. And we want it to be miles per hour. So I already see with the units that I'm going to probably divide the miles by the number of hours. So we have about 20 hours. Let's see, what would we round 1,276 to? That's approximately 1,300. So it depends. If it doesn't say what to round it to, then you get to pick in a way. And remember, it's whatever numbers you can do without a calculator, in your mind. So 1,300 divided by 20. The way I would do this mental math is I would divide top and bottom by 10. So then it drops out the zeros on the side. And then I just have 130 divided by 2. So then half of 130 would be 65. So those are the steps I would do in my mind while doing that mental math. So the car traveled about 65 miles per hour. All right, with the same scenario, if their car used 52 gallons of gasoline, estimate the average gas mileage of their car in miles per gallon. So now we're doing the miles divided by gallon. It's saying pretty much what we have to do mathematically there when we look at what our answer the units of our answer. And so if we know that we drove about 1,300 miles, and so 52 gallons is approximately 50. So again, doing this in our minds, I divide top and bottom there by 10. You get 130 divided by 5, and so that's 26. And the car averaged about 26 miles per gallon. All right, let's see. Using this same situation again, let's figure out what the approximate cost is of the gasoline if the gasoline averaged $3.95 per gallon. So we have from the last part of this question that it was approximately 50 gallons of gas. So if it's 50 gallons of gas that we approximately used, and it's approximately $4 per gallon, then what we would do is the $50 times the $4 per gallon and get an approximate answer of about $200 for this family to go from Portland, Oregon to Missouri, the Gateway Arch, right? So it's about 200. Here in our last example, we're asked to estimate the number of corn kernels in this photo. Okay, so one of the tricks that we can do when we're trying to count something that's very large is to divide it up into smaller things. So with this photo, we can divide it up into smaller squares and with equal areas. That helps. And so we're going to count the number of kernels in just one part of this. So if you notice, we have how many squares? 1, 2, 3, 4 on the width here, and then on the length we've got 1, 2, 3, 4, 5. So 4 times 5 is 20. So there's 20 total squares. And so when we zoom in on this one square, let's count them. And if we count a part of one, we're going to count it as being in the photo. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So those little pieces. So we have about 18. Okay, so each one might have about 18. And so when we see 18 and there's 20 of those squares, we would do 18 times 20 is about 360. So we would say there's about 360 kernels in this photo. And that's give or take, you could have gotten 16, maybe 20, and so on. So your approximate answer would be, it could be different, but it would still be about the same. So in wrapping up, I'm going to save you from any corny jokes and leave you with these questions to ask yourself. What is the difference between rounding and estimating? Do you remember? When is it more helpful to estimate than calculate an exact answer? Have you ever had to do that in your life, or do you think you might need to do that in the future? Will that be helpful for you? Think about that. And which real-world situations require good estimation skills? You can even think of which careers, what type of jobs that people might do. Will they be estimating more often than others? Okay, so I'll see you for the next lesson. Have a great day.